So you can see that's 12 minutes of audio right there. So again, very clean. All it really did is just add this simple import PDF number, which all this does is kind of opens up that PDF. It extracts all the text, it joins everything all together, and just like the first page, it just feeds it to the engine, and it creates a audiobook. So let me go back to the slide. Oops. So now this is an example of what that first page looked like, right? So try to keep it as minimal as possible, just to kind of show the concept. All we did was just take a hardcode string, we defined that in the file, fed it to the engine, and we created that. In the second stage, we got rid of that hardcoded string, and we actually uploaded a PDF, which is what we wanted to do here. We kind of just want to eventually build out a pipeline that actually uploads the PDF, and eventually creates a full formed audiobook. So it introduces two steps and replaces one. We get rid of the hardcoded string. We actually upload a PDF. We extract it and join it using file number. And the same steps as the first stage, feed it to the engine, and it creates out. So very simple. Now the second concept, or the second topic that I want to go over, is something called data normalization. So I did use some pretty standard examples for the first two. First one was just a very simple hard-coded text. The second one was a sample PDF, not too much going on there. But as you start coming across more complex PDFs, data normalization is something that we're going to go over. So I want to go over that. This is a book by Brian T. Cunningham. We're not going to go too much into the actual concepts of what this book is. But you can see here, you're just looking at it. It's not just a straight standard PDF, right? So this most likely is a scan or an upload, maybe even a design. And let me see if I can actually pull it up so we can take a look at it together. So if I pull it up, oops. So let's see. So it actually starts off like this. Edge kind of reformats it as best as you can, but this is the layout that we start off with. We open it, and as you see, once I kind of start going through the text, everything is kind of slanted vertically. So it's still text. We can still see everything, but it's not really the standard PDF format that we would get. It's not something that you would create and then print out, or even something that you would get faxed over to you, maybe. So it's something that might present a little bit of an issue. So let's go back. Let's actually see what running this looks like. So I did introduce a couple. So this is the third page. I introduced a couple of more steps. So I'm going to skip the first page, the cover art, and we're only going to do one page. The PDF has so much. Same concept, it's the same code-ish as the second page. All we're really introducing is just skipping the first page and we're parsing out one page instead of the whole lot. So I'm going to run this. You can take a look at what it looks like. This is before any optimization. It's kind of hard. It's kind of hard to do, but you kind of hear it sounds like a bunch of gibberish. There's nothing really going on there. And when I uncover this conveniently placed protection here, you'll see why. It's kind of hard to understand. When I print out all the text that you parsed out, you can kind of see it's a bunch of gibberish. There's not really anything there for the engine to create. And I can't even, I'm sure you guys probably also can't really understand what's going on here. But if I look, for example, this section of text, if you were to reverse these words, it would say, reading it from bottom to top, it says never give up backwards. So it's just the text, it's the same, all basically what the PDF is doing, or I guess what the library is doing, is it is able to find the text, but it's reversing everything. And it's creating all these new lines, it's putting everything on a new line and then reversing all the text. So we introduce this first page. So what we have to do in cases like this is normalize it, make it, we're just looking at it, essentially. We have to prep it before we feed it into the engine so that whatever the engine is creating is actually something that it can parse out. So I already have some predefined lines in here. So this script right here is the exact same as the previous script. I'm just introducing two lines, or a couple more, but these two main lines right here. This first line on line 15 is just reversing the string. So you have the right there, Olay, right? So all this is just reversing everything backwards. And let me just run that so we can see what happens. So now you can see if I print out everything, all the words make sense now. There's actual real English words in there. Never give up is there. Takes aspiring entrepreneurs, but if I actually fit that through the engine, let's see what that sounds like. So it's still putting out words, right? So it's actually creating the audio, and they're actually English words, but they're still kind of just like choppy. It's taking pauses, it's stopping, it's stopping, it's stopping. It still has these invisible. Most of you guys are programmers probably already familiar with this, but it has invisible new lines on every single one of these. So we're going to take an additional step, continue to normalize data, bring this kid up. Now, if I run the same script again, you see now what's right. Now it's clean. We just extend this. Now it looks right. Now it looks clean. It's better formatted. It's got a bit of love and space. Now if I listen to it. Small business consultant understanding practical knowledge. It's still robotic, but we're still using standard TTS, but now it's more fluid. Now it's kind of continuing on. It's not stopping. Whenever it wants to, it's actually reading out as best as it can from real conversation, which is good. And in a nutshell, that's exactly what normalizing data is. All we're really doing is just kind of cleaning the data, just kind of prepping it. And this case only really works for this one PDF. As you remember from before, the previous sample PDF we had, they required normalization involved. It was just kind of right out of the box. But not all PDFs are made the same. Everything kind of just comes in as it comes in, right? Because PDFs aren't actually, even though they're kind of presented as text, they're more like visual. They're kind of just meant, they don't really exactly print out text onto a format. They kind of just stick visual onto there. So it kind of makes it difficult in some cases to read that. So in this diagram, you can kind of see, even though
there goes the path. Oh, yeah. So,
TV still. This? Let me know when it's back. Okay, cool. We're back. You're good. So, okay, so, yes, as you can see, so the first workflow still works just fine. We just take that PDF, we run it through the extract text. That's it. We feed it to the engine, and it still creates something that we can use. It's still clean, it's still proper. It sounds better with Neural, but we'll get there. But in the case of Never Give Up, even though we're still extracting text and joining, we need to introduce that additional step by normalizing the data before feeding it into the engine. If not, there's no clean data for it to use. So that's kind of the complexities that I have heard to in trying to create that. Is that not every PDF uses the same workflow, and then detecting when to automatically or dynamically use one or the other is always a little tricky. So that's just one. So one of the next concepts I'm going to is optical character recognition, which is just a separate AI aside from text to speech. And for that one, I want to introduce a new PDF. We're going to be using the 0 to 1 by Peter Thiel with late masters. And OCR is a little different because that one requires us to turn the PDF into an image first. And the reason why we have to do that is for a couple of reasons, but let me just show you why. So for the previous page, I have removed a lot of the normalizations. We're going back to one of the previous stages, keeping it very clean. Still keeping the skip. We're only going to do one page for this one, but we're just going to be opening the PDF. We're seeing it in line 7, and feeding it straight into the engine. Hide that for now. Let's run this. And if we listen to it, actually, maybe let's actually open up a PDF first, just so we can take a look at it. And when you look at it, there's not really anything strange that pops out, right? It looks pretty normal. It looks like standard text. Everything is legible. Everything looks fine. You wouldn't expect any issues with a PDF like this. So most of the content, or I guess it does start at page 5. That's also why in my script, I skip until page 5, and that's actually when we start to read. So let me run it again just so that it's clear. PDF looks fine. Let's feed it into the script and see, see what that sounds like. So if I play that. It's kind of hard, so let me slow it down a little bit. So it's more gibberish, right? You can't really make out exactly what it's saying, but it's not, it doesn't sound like what the text that we see is, right? So if I unprint this out, we could take a look at what's going on. And as you can see, I didn't save it. So if I expand this, you can see all of this text right here is not what's actually on the PDF. So it's having some issues actually decoding what's on there. And that might be because for a few reasons. One of them might be because of the way that it was saved. They didn't want to intentionally make this available for anybody to download. So sometimes they'll kind of just add a layer of encryption just to kind of keep it from being parsed out like this. And it makes it
not impossible, but it makes it difficult for us to use the existing pipeline to kind of just feed it into the engine and just run with it, right? And even normalization might be a little too difficult because we're not even really sure what this is or what it's doing. I can't make out, it's not like the first stage where everything is kind of reversed or backwards. It's just a bunch of letters capitalized and in some kind of code. So what we do in this case is we introduce something called OCR, which is, I think I have the slide for it first. So what we're going to do is introduce a couple more steps. We're going to be introducing, for one, a second layer of AI. I think it's with smaller terms, so it's more like machine learning-ish. We're going to be using Tesseract to actually scan the page as an image, and it's going to detect text on there. So it's not going to parse it out like it would with a PyPlumber. We're going to turn it into an image. Tesseract is going to gauge out the characters from the pixels of that image. And then we go back to the standard workflow of actually extracting the text, putting everything together, and then feeding it into the engine. So that's what that looks like. So this is OCR. As you can see, it's added a little bit more. And really all it is just kind of this section right here. And like I had shown before, now we're actually going through each page, turning it into an image, and then Tesseract here tries to extract the text from that image in our PDF. And just like we did before, we kind of just feed it into the engine. So it's a completely different path now. You could say it's like normalization, but it's almost like something you can't even really do using standard, like if-else statements. You kind of have to go a different path and use OCR, because we didn't have to use OCR before. It's operations like this are pretty heavy because you're introducing a level of AI-ish, smaller, but it does kind of add to the runtime to these things. So let's run this. And let me print it out too so we can see it. So let me print this out. Oops. See, now that same text that we were extracting is a lot more legible now. So now we can actually make out words that were coming out of that PDF. Blake Masters took detailed class notes, which circulated far beyond the campus. And words are obviously, like, these words are going to be a lot easier for the engine to kind of parse out and read. So let's run that here. Oh, actually, I think saves it to 6. Yeah, so it's 6.
Blake Masters took detailed class notes.
Right, so that's a separate pipeline to running this, and it's pretty cool. So one of the last concepts that I kind of wanted to go over, and this is where we actually start introducing real neural text-to-speech, not some of the robotic standard text-to-speech we've been using. And let me just kind of go over. I'm not sure how many of you guys have heard of Hugging Face. I'm sure maybe most of you guys have, right? It's almost like, you could say it's the GitLab or the GitHub for AI. They host a lot more data sets, or they host data sets and models for you to download and extract and utilize. And we're going to be using that for our snippet of code. So I'm going to go back from using the OCR example, because I don't want to be using OCR and this AI speech at the same time. So let's look at stage 7. As you can see here, keeping around the same code, we're using normalization here because we're going back to the never give up PDF, which required some normalization. Everything was kind of reversed and there were some empty spaces in there. And in here is where we actually introduced Kokoro. So before I run this, I kind of want to briefly go over, where is it? Kokoro. So this is the Kokoro model that I'm using. It's an open sourced text-to-speech model. It's available to download. And what this team, I'm pretty sure it's a team, did is they created a very high quality text-to-speech model to use. And they only did it with, I guess, total $1,000. But this version one that we're about to view, they did it in under $600. So they got 500 hours of the A100 GPU. They ran their training scripts on this model, and they were able to procure, or I guess they were able to create a model pretty high quality. So we're going to use this model aside from the PyText engine we were using for the Never Give Up PDF. So let's run that and see what that looks like. It might take a little while for this. Yeah, so I was taking a look at this. I'm not sure if there's a higher quality model that came out. It's been pretty big for a while. I'm not sure if something newer came out, but it's still pretty good. Yeah, so I think this might take a while. Luckily, I made a sample beforehand. I am running everything on the laptop, but I want to show you guys what running Kokoro would sound like. And hopefully, let me raise the volume.
Both brushed off my concern, saying, "You'll do just iffy." I don't know what the hell to say to them. I told Ed and Jack, panic, original investment.
So a lot better, right? A lot better. So taking the concepts of everything else that we learned, using data normalization when we need to, using OCR when we need to, or even not using any of those when we have to, taking little bits of those concepts and creating a real pipeline and using some of these open source models that we have access to. Maybe not Hugging Face anymore. I'm not sure why it dropped so much, but it's there's a lot that you can do to kind of create an audiobook nowadays. There are a couple of gotchas here and there. I didn't get a chance to cover everything that I wanted to, but I do want to go over one last thing. So last year, when I was trying to kind of build something out, I wanted to take a shot at a startup, right? I ended up creating a full application. So I was creating the front end, I was creating the back end, I was hosting everything in AWS. You can kind of see in this blue spot, I was using React Native to build out an iPhone application and some browser stuff. I was using AdMob to collect money through ads. So I was trying my best to make it as free as I can. I was hosting everything on AWS. Most of the backend was kind of running through the API layers, and I was using Lambdas to kind of parse out a lot of the documents, handle uploading everything, storing everything in S3s. And I was using AWS Cognito to kind of host users, use those IDs to reference documents that were hosted in there. And it got pretty far. So I learned a lot from kind of just building this out and testing, uploading stuff, and listening to things, wanting to get as close as I could to to Spotify or Libby or Kindle, but didn't quite get there. But I did learn a lot kind of just building this out. So I did kind of want to cover this at least and just show you guys some of the scripts that I have built out. And it's pretty cool. I kind of want to open the floor for any QA in case there were any. And if not,
Have you looked at using OCR by PDF?
yeah, so I think Tesseract, I didn't know this until a little bit before, but I think Tesseract hasn't had an update for about 2 years. So there's like easy OCR, there's like PDF OCR. Google used to maintain OCR, Tesseract, until 2017, and then they just dropped it, and now they offer Google Vision. So Google Vision, and then AWS also offers Textract. So those are a lot higher quality. Tesseract is kind of like, every now and then it's kind of hit or miss. But there are some very high quality OCRs out there for sure. I haven't heard of OCR PDF, but
It's built on Tesseract, but it has such like abstraction, like it'll OCR back into the PDF itself.
Yeah.
So, like, it's flat, you I use it at work for scanning a bunch of the office documents.
Yeah, absolutely. I think I think that the technology is definitely kind of exploding up. So it's pretty great. Yeah, any other questions?
So what made you really want to go down the route of like converting text to speech to like such a hard scan?
For me, it was more, I had a lot of time throughout my day in my commute. At the time, I was trying to train for a marathon. So running for a couple hours, I was getting tired of listening to music. So I really wanted a dynamic way. I couldn't really find a very clean application that would allow me to upload a PDF and have me listen to it. Like I could have Spotify or Libby. There were some, but the text to speech was either very standard, like the robotic kind, or I had to leave my phone on to listen to it. There was no bookmarking. There was no like, a lot of audiobooks have a feature where you can listen to something at 2 speed or 3 speed. And I couldn't find all of that feature richness that I wanted with like a dynamically uploaded PDF. So I kind of wanted to take a stab. I still kind of use it back end every now and then for some stuff that I have, but when I was trying to offer it as a product or building something out for myself, I was bottlenecked by the costs, AI costs, expensive. So what was it? That was last year. Last year for me, yeah. Yeah. But that's it.
Do they happen to have like, I think people think about making PDF or manual text, making it into audio consumption, obviously allows people to do a bunch of different tasks while consuming, right? While listening to information.
Mhm.
My question is there anything out there yet where you can choose the voice of someone that you want to listen to? Like, I guess for me, it would be like Morgan Freeman or Medea, you know. Is there an app like that where I can choose the voice that I want to relay the audio version of a book or text?
So when I was building out this, a lot of what I was trying to do, I mean, I was trying to be very serious about it. And there was a part where I decided to start doing my own market research. And I was looking at competitors that were doing it. And there are some big startups. The biggest one that I could think of is Speechify. Speechify, yes, they have like 100 and something different voices to pick. And yeah, they have a lot, but I think they were more marketed towards, they were marketed as a accessibility tool because the founder has dyslexia. So he built that as a tool for himself. But they've kind of exploded upwards. They have a lot of voices, and I think they're offering it between like 150 to 200. It might have gone up since I last looked at it last year, but yeah, they have a lot. And something I did want to kind of go over. I didn't get a chance to because it was going to take way too long. But training an AI model nowadays is not too difficult. You can kind of make a voice. You can make a model for yourself. You would have to spend a couple hours kind of reading text and kind of, maybe like 6 hours reading through a script with like a variety of words. But you could even train something like that and build something out for yourself for cheap too. So I think text to speech is kind of, LLMs have gotten pretty big. I think at some point text to speech is going to get there at the same time. Yeah. Questions? No questions?
Do you feel like the impact of audio versions of text when it comes to childhood development and learning, do you think that's more positive or more children listening versus the traditional reading like we did?
Yeah.
We went to bookstore, book fair.
I think it's tricky. I think it's pretty detrimental, but I think the reality is that we're heading that direction anyways. Because I couldn't even just like, why couldn't I just sit down and read it either, Like nowadays, there's so much to pay attention to. There's so much information coming at you, and even tech is growing at a rate that's so hard to keep up with. I think text to speech and the tools are going to be helpful. They're going to be resourceful, whether we like it or not. Yeah. So.
That was something that Warren Buffett said he was real. One of the success principles, like read every day. Like
Yeah.
read every day. I forget how many hours you read a day. But I from different people that I've listened to or watched, they always like reading, and it's crazy because it's like, well, we're working. We don't have time to think of a book and read,
Yeah.
So universities are like a savior for people who are, working 2 or 3 jobs, maybe Uber, and I can listen to it while I'm doing whatever. But I feel like when it comes to kids, it's like, it's bad enough they have social media.
Yeah. I agree. Okay.
Let's just say that understanding comes from building, reading, you're deciphering something that's listening, internet is a different part of the brain. So you're pretty much actually something that's deciphering, trying to figure out what this symbol is and processing, comprehending, etc.
Yeah.
Yeah.
Yeah. That's it for me, guys. Thank you.
Cool. Thank you for that, Angel. I have just a couple things to wrap up with. I'll share my screen, I think. If I know how to do that, give me a second. I know. There we go. It'll slowly load. But yeah, thank you for presenting, Angel. I know we just gave a round of applause, but can we give one more round of applause for yourself too? So I appreciate it. So I appreciate everybody for coming out and enjoying the time with us here. We always hear from 6 to 8 o'clock. So always plenty of opportunity to network and hang out with people. Collaborate if you want to collaborate. This is also kind of an open announcement too, of like if you're ever interested in helping with ACM San Antonio or being on the board in the future, let us know. Come talk to me. Come talk to Gene. Come talk to Mark Robinson whenever he's here again. But yeah, there's always opportunity to be involved in your tech community here in San Antonio. But yeah, cool stuff happening. We already have most of our events planned for the year, and also a big announcement. I don't have like graphics and stuff yet. We're working. But we have our next event happening in July. And when I say next event, it's multiple events. Is anybody here like building video games or like looking at the video game world or video game development, stuff like that? Cool. So we're about to have a whole month of that called Velocicode. It's going to be the second annual event that's happened. So we had it last year in June. This year it's in July. It'll start and kick off on July 1st in this space on July 1st. We'll be here kicking off. We'll tell you the rules. We'll tell you stuff. Is that me? That's me, isn't it? Okay. We'll be over here. I'll quieter. We'll be here on July 1st. I am so sorry. Oh, that's you. I thought I muted it. Apologies. Give me a second. Okay, now we're back. I thought I muted him. That's on me. Yeah, be here in this space on July 1st, kicking off, doing all kinds of stuff, telling you the rules. It'll also be a teamwork building event. So if you're looking for a team, if you're a media designer or a artist or the game developer and like that kind of like space, it'll be an opportunity for you to come together and find someone else that's also looking for team members. But what does that mean? Has anybody else been a part of a hackathon? Ever done a hackathon, participating in college, outside of space? Well, this is also similar to that. We just call them a game jam. Game jam is just a time to build a game and you have a limited amount of time. The cool thing about this is that while you bring previous stuff to the event, you have to build with the theme in mind, which is only announced on July. So you come there, you build, you have the whole month to build. We have 3 now. That'll be July 1st at kickoff. the July 17th, which is a Friday, of a playtest night. So those who have start building earlier can come and get like immediate feedback from the community. And we'll also have some superlatives. And then we the official on August 1st. I wasn't going to do it on the 30th because that's a Friday and I work and I don't want to do it after work, so it's not happening. So it's happening on August 1st. It's a Saturday. Similar if you went to the AI showcase. It's just a chance to show off. You'll be judged and we'll have prizes for top winners of the challenges and or tracks. So a fun amount of events planned out. Keep an eye out on those announcements. I'm hoping to have a lot of those announcements go out by next week, and then we'll go from there. I know that was a lot of blabbering on, but we do also have our next few events lined up too for the year. So on September 9th, we have Jacqueline coming to talk about Before Identity, Verifying the Human Piece. That's our next general meeting in September. And then we also just got a title confirmation, very loose, called Bootable Containers from an individual on November. So keep an eye out for those. Those are ACM planned events and months that we will have our events. I also like to introduce the community. If you didn't know, there's all kinds of events happening, not just in ACM San Antonio, but San Antonio, Texas in general. We have Bite Night coming up at ATC at Zealotcam. We have the Geeks and Tech Tuesdays that's happening here at Geekdom on Tuesday. It's like an all-day event with a workshop, all kinds of fun stuff to get involved in. Open Source Builder Nights, that's also ATC at Zealotcam. And, you know, I was going to put some asterisks, but I think it's good to just be upfront about it. The DEF CON group is having a talk about hunting down sex predators. So they are a very interesting group. I always like listening to talks. If you can make your way out there, it's Lakeview College on, what is it, east side, west side? I'm always so bad at whatever side San Antonio is. East side? Yeah, east side. They're over there at Lakeview College. Definitely check them out every last Thursday of the month. They always have conversations. They're also having an anniversary in June. So there's a lot of twos this year, if you didn't know. I also like to give thanks to our partners, DevSA for helping in partnership with Geekdom, Geekdom for providing us the space, and then a big call and shout out to our full members who are helping support the organization for the food, the equipment, the time, their contributions to the organization. So I appreciate all of y'all. I also want to add that we always like to request feedback. If you have a moment to share your feedback on today's event or previous events you've attended, it's just a Google Forms link. That'll be saved in the live stream. You can always go answer it later. But with all my blabbing, that's kind of it. So if you have any questions, thanks for attending and thanks for coming out, y'all. Feel free to finish off the pizza for me. Thank you.